All right, so today I'm going to be talking about the first year of our pilot study, our results from Southern Humboldt County. So before I get started, I just wanted to acknowledge my colleagues that also worked on this project. So in addition to myself, there's Elijah Portugal, Dr. Jason Wan, and Kelly Souza from the Fisheries Branch, as well as Joseph Kermish-Wells and David Manthorn from our watershed enforcement teams in our regions. So in this presentation, I'll give the background on why this study was initiated, the location and development of our study, discuss the methods and analyses, all of which sets the stage for the future direction of our program. So cannabis cultivation for recreational use was legalized in California in the fall of 2016. This legislation also legalized the cultivation of cannabis at the commercial or farm scale. Subsequent legislation established the regulatory framework in which the Department of Fish and Wildlife and the State Water Resources Control Board were given broad conditioning authority on the California Department of Food and Agricultural licenses. And the purpose of the additional conditions were to fill gaps in species and habitat protections. And additionally, CABW and water boards were also directed to address concerns that cannabis cultivation could be or will in the future cause substantial adverse impacts on fish, wildlife, and the habitats upon which they depend. And so if one of these two agencies make a finding that cannabis cultivation is causing substantial adverse impacts, then CDFA shall not issue new licenses or increase the number of new plant identifiers in that area. So it's really this directive which is our nexus with the legislation. And this responsibility necessitates the development of a monitoring program to investigate cannabis-related impacts. Examples of cannabis-related impacts include water diversions, which can lead to dewatering, land clearing and grading, which can increase sedimentation to streams, can decrease water quality, all of which can lead to decreased habitat quality and quantity. Even though these impacts have been observed on the landscape, there's been little empirical evidence to date to quantify the potential impacts to the aquatic environment. So to begin to assess cannabis-related impacts, a pilot study was initiated by Fish and Wildlife in 2018. The goals of the pilot study were to assess concerns related to substantial adverse impacts of cannabis cultivation in specific watersheds, to test study design and methods for assessing aquatic habitat quality, and to inform the development of our statewide cannabis impacts monitoring framework. So our three study streams are located in the headwaters of the Mattole River, which is in southern Humboldt County. They were Eubank, McKee, and Van Arken Creeks. They're in the center, north to south. These streams are all naturally, seasonally intermittent in some years, have experienced decades of logging-related impacts, and are home to state and federally listed species. And our watersheds were chosen because they share similar watershed characteristics, such as what's listed here. They have similar land use histories, and we have landowner access there. So using this similar watershed approach in our analysis allows us to attribute the differences in the results to differences in land use and not natural variability. So on this map, cannabis watersheds are located in green. So these two, Eubank and McKee, have cannabis in the watershed, and that was determined through aerial imagery analysis. And Van Arken was our reference stream here in brown, and these red segments are where we sampled. So the objectives of the study was to compare hydrology of streams with varying levels of cannabis cultivation, to conduct watershed scale mapping of cultivation sites for estimation of water use for cannabis, and to compare water quality parameters in these three streams. So what we did was we deployed 4 continuous dissolved oxygen loggers as well as 2 pressure transducers in each of our 3 study streams. And these systems are not gauged, and so that's why we had to deploy those pressure transducers. We also took at least 5 discharge measurements over the study period to establish the stage flow relationship that's necessary to create the hydrograph. And these methods allowed us to compare the rate of change in flow, dissolved oxygen, and temperature between our 3 streams. So this is a plot of our mean daily discharge measurements over our study period. And so we have here, okay, well, good thing I'm going to explain it to you. So the green one here is Eubank. Purple is McKee, so those two have cannabis, and orange is Van Arken, our reference stream. So what you can see is that our cannabis streams actually start out with higher discharge. And sorry, this is time, and so this is May through September. I'm not really sure what happened. Yeah, that's weird. All right, and so if I zoom in on the late summer base flow period, so this is August, this is July, this is August, this is September, you can see that our treatment stream, so Eubank, green, McKee, purple, disconnect 2 to 3 weeks earlier than our reference stream Van Arken here, and these dates are when our streams reached the stage of 0 flow. And the rate of stream flow decline is significantly different between all 3 of our study streams, with our treatment streams declining faster than our reference stream. So in order to quantify the amount of cannabis cultivation in our watersheds, we manually digitized grow sites using aerial imagery. Hoop houses and greenhouses were identified and outlined in green, and outdoor gardens in orange, and the footprints were measured. So as you can see on this map on the right, our study streams spanned a gradient from 0 cannabis in our reference stream Van Arken to 12 acres in Eubank. And additionally, we also measured ponds and tanks. And so these measurements are estimations because we can only measure what we can observe. So anything that was growing under dense canopy or within a structure such as a house, not a traditional growing area, then it wasn't included in this analysis. So these are just estimations. All right, and so these estimations by grow area and type, as well as water source, went into our modeling effort for cannabis water demand and extraction. So estimates of water demand for cannabis, as well as domestic use and other irrigated crops, were modeled based on equations and methods from the papers listed here. I don't have time to go over the details of that. But in this plot, this is runoff just to standardize the water usage. This is time, and these are our 3 study streams. So Eubank, that was our high cannabis stream. McKee's intermediate, and Van Arken was our reference. So what you can see here is that in our cannabis streams, demand for cannabis, which is here in green, exceeds surface water availability later in summer. However, it's difficult to determine if cannabis was the cause of stream flow decline because as you can see, they all eventually go dry, including our reference stream here. And through this analysis, we discovered that underlying lithology in Eubank Creek is actually different than Van Arken and McKee. It has naturally water-shedding properties where you would expect stream flow to decline at a faster rate there. And so we're unsure if that lithology is amplifying that decline in the presence of cannabis or despite cannabis. All right, so in addition to stream flow and water demand, we also monitored water quality. The criteria for which to be selected as a water quality parameter included responsiveness to cultivation. It had to be biologically meaningful to fish because federally threatened steelhead rear in these streams year-round. And they also had a published threshold with which we could compare our results. Collection methods that were rapid, repeatable, and ultimately scalable were also desirable because of their potential inclusion in our statewide monitoring framework. And so for those reasons, in the pilot, we chose benthic macroinvertebrates, water temperature, and dissolved oxygen as our parameters, and those are the collection methods underneath them. So for benthic macroinvertebrates, when we compared the abundances of the BMI taxa and the streams, there are actually many similarities between Eubank and Van Arken. These are the only two that were included in this analysis. And so upwards of 90% of the observed taxa in the streams were common between both Eubank and Van Arken, and there were no major gaps in taxonomic groups. And so what also may be apparent is that there are differences in abundances of the taxa in the streams, and so you can see that Van Arken has more of these particular taxa here, and Eubank has more here. And this difference is actually statistically different. We did a non-metric multidimensional scaling and associated PERMA-NOVA analysis on the abundance of the taxa, and they do separate out by stream, indicating that the abundances of the taxa are different. However, this difference in abundance may not actually be ecologically important. And so to further illustrate that point, I compiled a subset of common biological metrics that are used in bioassessments. And we ran a Wilcoxon analysis on 43, 15 of which I displayed here. And 75% came back as not statistically different between the two streams. And so if you look at common community metrics such as taxonomic richness, Shannon diversity, and CSCI scores, which is up here at the top, as well as tolerance values down here, you can see that they're not different, indicating that members of taxa, measures of diversity, and overall stream condition are not different between the two streams. However, evenness, unsurprisingly, came out as statistically different. Although if you look at the scores, they're actually pretty close there. It's a marginal difference. So down here, these are the functional feeding groups. And as you can see, there's statistical differences in almost all of them. But sometimes the differences here are small. And actually each of these behaviors, the proportions of each of these behaviors actually rank out to be the same in both of these streams. And so for instance, they're both dominated by collector-gatherers, and then so on down to having the least represented by collector-filters. And so the communities are functionally similar. And so for the BMI, there was no smoking gun indicating that our treatment stream Eubank was in any worse condition than our reference stream Van Arken. Next, we examined water temperature and plotted them against Salmonid thresholds from the literature. So this is a plot of our observed mean daily maximum water temperatures for all three of our study streams. And in this particular analysis, stream temperature was better predicted by air temperature than by stream flow. So I'm not showing you modeled results here. Instead, I just wanted to show you that water temperature over a study period stayed within optimal conditions for the most part, except in the peak of summer when air temperature was highest, it did get into that suboptimal range. But if you look at the period of when the streams were actually disconnected, which was down in here, they're well within optimal water temperatures, and so water temperature was not a limiting factor in these streams. This is a plot of our mean daily minimum dissolved oxygen measurements overlaid with the date of disconnection from the hydrology analysis I showed you earlier. And so as a reminder, this was Eubank, McKee, Van Arken. So on this plot, you can see that as streams are beginning to dry, that's when the dissolved oxygen measurements start fluctuating. And once they reach that period of disconnection, they just really start declining. So when I overlay thresholds of daily target for maintenance of cold water species from the Water Board's North Coast Basin Plan, as well as thresholds for salmonid acute mortality from the literature, you can see that once the streams reach that period of disconnection, which was in here, all three of the streams fall below that daily DO target, with the treatment streams spending significantly more time in that acute mortality zone. And you can see that in the table that Eubanks and McKee were below that threshold 2 to 3 times more than our reference stream. And just like stream flow, dissolved oxygen decline was significantly different between all three of our study streams, with our treatment streams dropping out faster and sooner than our reference stream. So in conclusion, stream flow and dissolved oxygen levels decline significantly faster and earlier in treatment streams. Water extraction for cannabis is estimated to exceed availability in summer. Salmonids in our study streams containing cannabis may be experiencing longer periods of suboptimal conditions. And although BMI differ in relative abundance in some community metrics, those differences might not actually be ecologically important. And so, although our hydrological and biological results indicate that there may be impacts to steady streams from cannabis cultivation, disentangling cannabis specifically from other human impacts, as well as natural variability, is really challenging. We also found that using a paired approach is in itself challenging because of the difficulty in finding good pairs. And correctly identifying cannabis as the cause of impact is going to take a multiple lines of evidence approach. And in order to do that, a long-term and larger monitoring effort needs to be implemented that can span the gradient of human and cannabis impacts, so that impacts from cannabis specifically can be more readily identified. So in 2019, we reoccupied our 3 paired watersheds to see if patterns that we observed in 2018 would hold true in a different water year, as well as with the forbearance from stream flow diversions during the low flow period, which went into effect in 2019. We also added data loggers to decrease variation in dissolved oxygen, temperature, and stream flow measurements. We also recognize that there are more metrics still left to explore, so we're including metrics such as the riffle crest thalloid depth to examine the relationship between that depth and flow and dissolved oxygen. We're adding road density and distance to streams into our models and analyses. We also added a wildlife component to the pilot study in 2019, which included the addition of small mammal and camera traps, as well as acoustic recorders. And those methods were conducted through the wildlife branch's cannabis and non-game program in the Department of Fish and Wildlife. Finally, all of this work that's been done is informing the development of a cannabis statewide monitoring framework. And so currently, we're in the early stages of development, where we're working with our wildlife counterparts to create working objectives, select metrics, and develop a study design that can be implemented at a statewide scale. So we try to be as collaborative and transparent as possible in this effort, so we'd like to acknowledge all the folks that helped us in the field, let us borrow equipment, trained us, the people that reviewed our study plan, gave us input on design, analyses, and helped us obtain landowner access. So with that, I will take questions.
Interesting study. Do you think that the absence of seeing an effect on the macroinvertebrate population might have been related to when you did the sampling related to the deteriorating water quality?
It could be. I think that, so because of the length of this talk, we could only go into a little bit of detail about how we sampled, and so those samples were taken that I presented were taken in July, and for those we collected 8 samples in each of the streams, but we also sampled all 3 of our streams in June, July, and August, just with 1 sample using the standard approach. And so the overall CSCI scores were not different between June and July, and the stream still had, all the streams still had surface flow in July, so I don't think that results that we saw in July were attributed to that. Possibly any effects that we saw in August could be because of the decline in stream flow, but we didn't do enough sampling to be able to statistically compare them in August.
Yes, thank you for your presentation. I was wondering if you could put up the slide with dissolved oxygen on the screen for a second, and I'm just curious about that. Maybe the next one, or I think it was that one, yes. About the differences between your control site and your treatment sites, and if you've considered looking at differences in dissolved nutrients, differences in organic matter between the treatment sites and the control site that might be contributing to this pattern that you see in your slide?
Yeah, and so when we were developing this study, we talked about whether we wanted to collect water graph samples for nutrients. You know, we talked about POSIS. We talked about all of these methods. And so we didn't do them because we were in a tight time constraint and we didn't have contracts in place to be able to get those samples processed. And so they are potential metrics for inclusion in our statewide monitoring framework, but for the pilot study, we just didn't have time to get those methods in place.
I was curious if you could tell us a little bit more about the statewide monitoring kind of plan, or which kind of parties are involved with that, and how you might share that information in the future.
So right now, we are really just developing it. It's 4 people in fisheries branch and 2 people in our wildlife branch in the department, and we're really just like still figuring out our objectives and metrics. It's very early stages. And so I think what we are thinking is going to happen is we're going to get, you know, this skeleton framework developed, have our internal regions examine it and get it out for general review in a couple of years, maybe. I think it'll probably be a while.
Hi, thank you for your work. I'm curious, since Van Marken doesn't have any homesteads on it, how is it that you can compare, like how can you say that it's a cannabis effect more than just a homestead in general effect?
Maybe I could take a stab at that. So we did try to.
Yeah, you need the microphone for this.
All right, my name is Elijah Portugal, and I was involved with this study as well. Hi, Katrina. But we tried to account for all water use in the watersheds that had humans living in them. So, you know, we did the estimates of water extraction for cannabis using the approach that she mentioned, and then we also tried to estimate all water use, so domestic use as well as non-cannabis irrigation. So we identified anything that was being irrigated from aerial imagery analysis in late summer, and then tried to predict the volume of water associated with that. So from a water use standpoint, we were able to provide those different estimates, but as far as like disentangling impacts due to people just using the road network in these watersheds, you know, we weren't able to do that.
I would like to know whether when you had the DO's sensors and loggers attached to it, did you have like pH and conductivity sensors in it as well? And those might actually show some changes along with the dissolved oxygen.
We did not have pH until this year. We started including measurements of pH and alkalinity. In 2019, we do have specific conductivity measurements taken from YSI, so they weren't continuous measurements last year, but we haven't dug into, we haven't done that analysis yet.
Yes, I wanted to say a few remarks about cannabis. And I've never used cannabis or tobacco, and I'm not against it. I just need to say something about the motor thing. But I am a crop advisor, and so I'm basically CEUs on hemp and on marijuana. And there's a big difference in the agriculture that's from one to the other. So when you're talking about cannabis, if you've got a container agriculture, you do have more use of water. And to really make this make sense with the data that you've got to know how much illicit use is involved in that watershed because often the water is drawn for illegal potted marijuana that's hanging in the trees. And I know that because I just come from Calaveras County this morning, which just reversed itself again on cannabis. And I know that there's places where I run where I can see the marijuana plants hanging from the trees on public land. And so you've got a bunch of undetermined factors that could be involved in water use in this study that you haven't accounted for. And that bothers me a lot. There could be plants that draw, there could be agriculture that can draw as much water if it weren't cannabis. And you haven't even told me yet whether the water is drawn directly from the creek or whether it's an extraction process from the well that's actually lowering the water level in the creek. So it's really fuzzy. All this data seems to be really fuzzy to me.
I'm going to let Elijah answer that.
Yeah, I mean, I could take a stab at that. And obviously, we're limited by
what's available to us, right? And so, we did the best work that we could following in the sort of footsteps of other people who have done a lot of work looking at aerial imagery analysis specifically to try to come up with whatever kind of information we can find out about the sort of habits of water use of all different types of cultivators. So we fully recognize and understand that the cannabis cultivation community contains a wide range of different sort of water extraction practices. And so the way that we're getting at this, and let me remind you, this is a pilot study too. This is not something that we are necessarily going to be doing this exact same thing moving forward, but what the water use model that we used was one that was, and she again didn't have the time to really talk about the details of it, but it was a model that was developed by folks primarily at the Water Board, and it's described in detail in two different papers, Dillis 2019, and then another one with him as the lead, where he was working with folks from the Cannabis Research Center at UC Berkeley, where they basically developed this model based on self-reported cultivator data of people who were not actually being regulated yet. So it was actually more reflective of the patterns of extraction. And this is extraction from the watershed. This isn't just plant demand. There's a pretty big difference there. But they were trying to actually model the water extracted from a given watershed based on the self-reported data from something like 600 cultivators, primarily in Humboldt, Mendocino, and Trinity County. So this model we used that in a predictive way to basically say we don't know whether a given cultivation site that we identified in aerial imagery, whether they're regulated or not, we don't really care. We know that they're using water. We're trying to predict that. And so, we used this model. We know it's imperfect. We know that there's limitations to it. And we also know that, that we couldn't really get a good handle on well use. We know that that's actually the most common form of water use for cannabis in the state. And it's currently hard to get a handle on how many of them are out there in a given watershed. So anyway, we feel like the data on the estimates of water use that vary seasonally, so she again didn't necessarily have time to go into all this detail, but like we presented it on a monthly basis and we showed, how that changes through the season. But essentially we think that it was relatively an accurate representation of the water extraction profiles of people in that area, but without being able to go and knock on everybody's door, we couldn't get the level of field validation that we would want. So we recognize all these uncertainties and we're moving forward with that.
Thank you, Erin.